Lesson 2.5, Evaluating Absolute Value Expressions. This is day 1 of a 4-day lesson. Essential question, how can two numbers have the same absolute value? The question we need to answer before we get into the lesson is, what does absolute value mean? Absolute value is the distance from 0 on a number line. Alright, so the first thing we're going to talk about is what two numbers have an absolute value of 7. So we have to think about the distance from 0 on a number line. So what numbers are going to have a distance of 7? Which numbers are 7 away from 0? So if I start from 0, 1, 2, 3, 4, 5, 6, 7. So 7 has an absolute value of 7. And then I can also go the opposite direction. 1, 2, 3, 4, 5, 6, 7. So negative 7 also has an absolute value of 7. So the two numbers that have an absolute value of 7 are 7 and negative 7. What is the value of each of these? So they want to know what is the absolute value of 5, the negative absolute value of negative 5, the absolute value of negative 5, and the negative absolute value of 5. Alright, so let's start with the first one. We know that absolute value is always positive because distance has to be positive. You can't go a negative distance. If you're traveling, you're always going a positive distance. So if I take the absolute value of 5, so the distance from 5 to 0 on a number line would just be 5. The next one gets a little bit trickier. So if I look at just this part, the absolute value of negative 5, or the distance from negative 5 to 0 on a number line would be 5. But then you'll also notice we have this negative out in front here. It's kind of like the negative is outside of our absolute value lines. That means I have to put the negative in front of the 5. So my answer for that one is negative 5. Third one, the absolute value of negative 5, which we just said above, is 5, because the distance from negative 5 to 0 on a number line is 5. And then on the final one, the absolute value of 5 is 5. And then you'll see again this negative sign out in front, so I have to put that in front of my answer. So whatever is inside of the absolute value lines has to be positive, but if there's a negative outside of the absolute value signs, you have to tag that on in front of the number. Evaluate each absolute value expression if x equals 5 and y equals 3. So first I'm going to replace y with 3. And absolute value lines, if you don't make them bigger than your numbers, can look like 1. So I'm actually going to change colors for my absolute value lines from red to black. Okay, let's start solving. The way you solve absolute value expressions is kind of like PEMDAS. So I always think of my absolute value lines like my parentheses. So I'm going to do whatever is inside of those first. So 17 minus 3 is 14. Keep those absolute value signs until you're only left with one number. So now I'm left with just the absolute value of 14, which is 14, plus 23. If I add those together, I end up with 37. next one is x minus 7. So if I know that x is 5, so 5 minus 7. So then I'm going to, again, work inside of my absolute value lines first. 5 minus 7 is negative 2. So I have just one number inside my absolute value lines now. So I'm going to take the absolute value of that number. The absolute value of negative 2 is 2, plus 15 is 17. Again, we're going to evaluate each absolute value expression, but this time x is going to equal negative 3 and y is going to equal 2. So if I set up my problems, all right, so if I put my negative sign out in front, and then I've got my absolute value lines and then plus 9. So I'm going to replace x with negative 3 minus 7. All right, so again, I'm going to work inside of my absolute value lines. Negative 3 and negative 7 make negative 10. I'll bring down that negative sign in front, and I'll bring down the plus 9. The absolute value of negative 10 is 10, but then I have to bring that negative sign down and put it in front of the 10 plus 9. Negative 10 plus 9 is negative 1. Then I've got in my next one, negative 11 plus x times y, which is negative 3 times 2. Okay, so now I have a little bit more going on in my absolute value bars. I have adding and multiplying. So just like PEMDAS, we know that we have to multiply first. So negative 11 plus negative 3 times 2 would be negative 6. Put my little lines around my equation. Or I should say around my expression. All right, negative 11 plus 6 is negative 17. Minus 15. The absolute value of negative 17 is 17. 17 minus 15 is 2. And the last one, this time x equals 5, y equals negative 1, and z equals negative 4. 12 minus x minus y would be 5 minus, because of this minus, but also you'll notice I have a negative 1. So minus a negative 1 plus z, which is negative 4. Since I have minus a negative, I'm going to change that into a superplus. Work inside of your absolute values first, so I've got a 6 in there. So 12 minus 6 plus a negative 4. The absolute value of 6 is 6, so I'll drop my absolute value lines. 12 minus 6 plus a negative 4. Now PEMDAS tells me to add and subtract from left to right. So 12 minus 6 is 6. 6 plus a negative 4 is 2. Last one, negative y. So this one's a little tricky again too. This is negative y, but we also have the negative in front of the 1. So again, I'm going to go minus a negative 1 plus 5 minus 3 times negative 4. All right, so since I have minus a negative, change that to a superplus. So positive 1 plus 5 makes 6. Minus 3 times a negative 4. All right, absolute value of 6 is 6, so I can drop those absolute value signs. Minus 3 times the negative 4. So I'm left with subtraction and multiplication. So 6 times, or minus 3 times, negative 3 times negative 4 is negative 12. So I'm left with negative 6. Summary. Two different numbers that may have the same absolute value because this is the homework assignment for this lesson. It is not found in your book, it is just on this screen. So you are going to have to adjust this a little bit. You're going to have to copy these problems down off of the screen and then solve them in your notebook. So this is not something that you'll find in your math book. It's going to have to be copied from this screen and then solved on paper. Hopefully you can see all of our absolute value signs now. So there's a total of 10 problems.